Is it repeated addition?
It's like that, yes, it is repeated addition, but it's called what? I'll jump in. Go ahead. Say it.
I think it's called
You did it on Khan Academy. Go ahead.
simplifying algebraic expressions.
It is, but it's called, I'll just jump in and I'll say, because I want to make sure that you have an idea what I'm talking about. It's called combining like terms. So when I combine like terms, Amber, I have 2x here, another 2x, and another 2x. So how many x's do I have?
6.
We have 6x. So that took care of the x's, and what do I have left?
5.
5 plus 5 plus 5 plus 15. So when I combine the like terms, I end up with 6x plus 15. Now that's the long way. Then, what we talked about yesterday, how did we make it a little bit easier?
You can make it a little bit easier by making a square and putting a line through the middle.
Okay.
So you put the 3 next to the box, and all you have to do is multiply it by 2x and 5.
Right, we were talking about the visual model. But Jonathan, is there a way that we can make it even easier?
Yeah, if you multiply 3 by 2x, and then you multiply 3 by 5, it will give you 6x plus 15.
Very good. What we did was distribute the 3 through what we had. We have 3 times 2x, and then we had 3 times 5. So 3 times 2x, Jonathan, was what? 6x, and then we added, what is 3 times 5? 15. So, a simpler way to get the same answer. We can extend this and do the 2x plus 5 plus 2x plus 5 plus 2x plus 5. Or we can multiply through by 3. Okay? Do we see that?
Yes.
Okay, anybody have any questions on this? Because now we're going to go backwards. So I want to make sure we're all clear with the multiplying through and distributing through. Okay? Alright, so what we want to do now is we want to take that distributive property, a little bit more consistent and everybody sees where we're going. I'm going to start off with 24y plus 18. That looks like an answer to a problem we just did. This is where we're going to start, but now we're going to work backwards. Now we're going to try to end up at a product of a sum. So we want to start with that old concept we had of the greatest common factor. Who can tell me what the greatest common factor is between 24 and 18? 6. Our greatest common factor is 6. So now what we have to do is we want to break apart 24y and 18y into factors, one of which is 6. So in order to get 24y, what am I going to multiply 6 by to get 24? Joe Steve.
4y.
4y. So to get 24y, I multiply 6 times 4y. Now how do I get to 18, Fiona?
Multiply 6 by 3.
6 times 3 is 18. But now, as you can see, both terms have a 6 in them. So I can factor out that 6, kind of like when you're simplifying a fraction. When I have 2/8, and you tell me, oh, okay, there's a 2 in both, so 2/8 is equal to 1/4. You just simplified it. So now I want to simplify this using our greatest common factor of 6. So I'm going to take the 6 and put it on the outside of our parentheses. So now, what am I left with on the inside of these parentheses? Jonathan.
4y plus 3.
4y plus 3. If I take the 6 from here and the 6 from here and just physically move it out of the parentheses, I'm left with just the 4y and the 3. So now that gives me what we said in our objectives, the product of a sum. So taking this and working backwards to where we were before, I now have 6 times 4y plus 3. Now that looks a lot like what you were doing yesterday, doesn't it? So we've taken where we're going to start today and get back to where we were yesterday. But we can always check it because in math we love to check things. So how can I check to make sure that this is equivalent to this, Amber?
We would do what we did yesterday, or write it out 6 times, or multiply 6 by 24.
Sure. We can write it all out. We can write 6 of these, 4y plus 3 plus 4y plus 3 plus 4y plus 3 plus 4y plus 3. But we can also multiply, as you had said. So, what is 6 times 4y? 24y. And what is 6 times 3? Plus 18. So you can see that these two are equivalent. All we did was take this sum, this expression, find the greatest common factor and factor it out, and we end up with the product of a sum. So we're taking where we ended yesterday, and we're going backwards to where we started. Hopefully that doesn't sound too confusing. We're going to go back to where we started. So, let me throw up one other problem, and we'll talk about it. So this is 16g plus 4. 16g plus 4 is the sum of 16g and 4, but we want to factor out the greatest common factor. So think about it for a second. Think about what the greatest common factor is, and then I'll ask you. Everybody think they have an idea? Okay. Lyle, what do you think the greatest common factor is? 2. 2 is a factor, but is 2 the greatest common factor? Say it. 4. So let's go to the greatest common factor being 4. Okay. So now what we want to do is factor out the 4, divide out the 4 from these two terms. So 4 times what will get me 16g? 4G. Thank you. I just wanted you to be able to say it. And then 4 times what will get me 4? Fiona.
1.
4 times 1. So now, as you can see, we have a 4 in both of these terms. But we can take the 4 out and put it on the outside of the parentheses. So if I take the 4 out, what does that leave me? Notice, what does that leave me when I take the 4 away from both of them? What? 4g plus what? This 4 is coming out. So what's left here? 4g plus 1. Now, can I check this? If I have 4 times 4, well, 4 times 4g, what does that get me? 16g. And if I have 4 times 1, what does that get me? 4. So am I back where I started? Then I'm correct. Then we're correct. As we factor out this 4, that gives us now the sum, the product of a sum. Okay? Any questions before we start? Okay. So let's take a look, and I'm going to have you do this problem on either scrap paper or bamboo paper, and I'll come around. All right, I have 3y plus 9. So first, think about the greatest common factor, and then once you find that, you can factor it out. Great, but you don't want to forget the y. Okay. So when you multiply this guy through that and that, you're right. Good job. Good job. Perfect. Nice job. Great. Okay, that's right. But what did we factor out? So it's 3 times 1y is 3y. 3 is 9. Good. Yes. You're all set. Can you just here for 1 second? Great. All right, just another second. I think most of you have gotten it. Waiting for one more. So you can do this along and say.
Oh, that's the companion socks.
So we have 3 times what is 3y? 3 times 1y will get you 3y. Plus 3 times what will get you 9. Great. So we take 3 out. That leaves us with 1y plus 3. So when you multiply 3 times 1 is 3y. 3 times 3 is 9, and that's what we start with. Okay. Back up on me. 5, 4, 3, 2, 1. Hocus pocus.
Let's focus.
Awesome. All right, so I gave you 3y plus 9. Who wants to tell me what is the greatest common factor of 3 and 9? Jake one. What is the greatest common factor between 3 and 9? 3. So we're going to start with the greatest common factor of 3. Now we want to find out the factors. We want to know 3 times what, Jake one, 3 times what will get me 3y? 3 times 1y will get me 3y. And then 3 times what will get me 9? 3. So do I have a common factor that I can take out now? To the outside of the parentheses. What common factor do I have? 3. So I can take the 3 on the outside, and that leaves me what on the inside? 1y plus 3. So if I want to check this, if you're thinking, I wonder if I'm right, I can check this. How would I check this to see that I'm right? Amber. 3 times 1y, and that gets me what? 3y. And then I multiply 3 times 3. So am I back where I started? Awesome. All right. So let me see. You guys seem to get this. I want to see if we give you some different numbers. We're going to apply the same process, just with some different numbers. So I'm going to have 2 problems for you, and you can solve them both, and I'll come by and check them out. First one is going to be 2x plus 10. And the second one, we're going to do 15x plus 6. So think about greatest common factors. And then we'll factor them out. Okay, yep, that's the first one. Number 1's right. Yep. Don't forget, yeah, you can say don't forget your variable. Good. Does anyone? Yes. That's the first one, yep. Good. Great, nice job. Now remember, if you're waiting for me, you can always just go back and check and make sure that you're right. That's the good thing about inverse operations. You can go back and check. Don't forget your variables. Yes? Greatest common factor isn't 5, so there's no 5 here, 2. I want to check. Number 1 first. This, yeah, first. What number on the outside of the fence is 3 times?
2 goes into 2, right? It also goes into 10. Probably 10.
What is 3 times 5?
So 2 goes into 2.
All you're going to do is substitute. 15 plus 6y, but we want to call y by its other name. What other name should we call y? Yeah, you're just substituting for that variable. Okay. On me, 5, 4, 3, 2, 1. Chicka chicka. Boom, boom. All right. So 2 problems, very similar, but with different numbers, so we want to go through and check them out. 2x plus 10. What is the greatest common factor of 2 and 10?
2.
So we're going to use our greatest common factor of 2. So I want to factor that 2 out. You can help me all the way through. So if I multiply 2, what do I multiply 2 by to get 2x?
1.
1x. And what do I multiply 2 by to get me 10?
5.
5. So now I have a common factor here that I can pull outside the parentheses. And that factor is what? 2. So I pull the 2 on the outside of the parentheses, and that leaves me what?
1x plus 2.
1x plus 5. Now if I check this, and if I check this, I have 2 times 1x, which gets me 2x, and I have 2 times 5, gets me 10. Nice job. So we're right back where we started. It's a good way to check. Now for 15x plus 6. Joe Stephen, what's our greatest common factor?
3.
Greatest common factor in this case would be 3. So now I want to use that factor. So how do I go from here?
You got to do 3 times 5x
Okay?
plus 3 times 2.
Okay, so now I have a common factor of 3 in both of these. So now if I take that factor out, outside of the parentheses, what does that leave me inside? 5x plus 2. So now we can check it, right? 3 times 5x? 15x. And 3 times 2? 6. Okay. Show of thumbs. How do we feel? Like we understand? Little bit of iffiness? Hopefully nothing. Couple in the back. Little waving in the back. All right. We're just going to practice a few more of those because they can get a little bit longer. But first of all, I'm just going to give you, let's say another one.